So good day everyone, my name is MONTOYA. Me and my groupmate CORLEONE and JOREL ZALDARRIAga will be discussing about our study, which is entitled Determination of Shelled Corn Damages using Colored Image Edge Detection with Convolutional Neural Network. Now this video presentation was made in accordance for the fulfillment of the requirements of our course COE 200-2L for the third quarter of this school year 2019-2020. Now for our statement of the problem, the methods for evaluating and qualifying corn kernels that are employed by most farms in the country are only done by manual human inspection, and these methods are inconsistent, which results to inaccurate findings. This is true because most inspectors evaluate each corn kernels individually, which will result into inconclusive and inaccurate findings when dealing with large amounts of samples. Now for a general objective, these studies aim to determine the damages of shelled corn kernels through the use of a convolutional neural network which integrates and employs image processing algorithms. Now we'll go more over this with our specific objectives. Now for our specific objectives, for our first specific objective, it is to develop a prototype that is capable of spreading shelled corn kernels evenly on a tray and handling a camera to effectively assess 3 different angles of the test data. Now in order to achieve this, we've designed a simple wooden tray, and under it we've coupled it with 2 vibration motors which will facilitate the spreading of the corn kernels, and there are 2 panels going out from the sides of the tray which will also handle or also house the 2 camera stands which will be used for the 2 different camera angles aside from the top angle, which will be manually captured by the inspector or the user. Now for our second specific objective, it is to implement a colored image edge detection algorithm designated to detect the edges. Now when we capture our sample image or sample data, there are dead spots or empty spaces. This algorithm will help filter out those empty spaces. Now for our third specific objective, it is to use a convolutional neural network model to process data on the physical deformations of shelled corn kernels or on the samples. Now the convolutional neural network will assist in categorizing whether it's a specific type of damage or a healthy kernel overall for each sample. Now for our fourth and final specific objective, it is to test and validate the convolutional neural network model on correctly determining corn kernel damages with an accuracy threshold or target of a 93.5% rating. Now for the scope and the limitations of our study, the first one is this study limits the dataset to local corn produced in the country, specifically the yellow corn. Now the white corn is not included in this study because it reduces the number of conflicts that we have on the damage types on our study. Now for the second scope and delimitation, the amount of shelled corn kernels to be processed will be limited to a total weight of 100 grams for every assessment or for every sample. Now this is the reason for this is because corn kernels are of different sizes and shapes. Now defining a number of shelled corn kernels per sample will lead to more irregularities for the sample evaluation. So we agreed on normalizing the weight of 100 grams for every sample. This will also be the basis for the evaluation, which is also the standard for the U.S. Department of Agriculture when evaluating or qualifying corn kernels. Now for the third scope and delimitation, the factors that are considered in the study is limited to dryer damage, heat damage and dryer phase, and other colored corn, which is in type A and type B. The ones that are not included here are the ones caused by toxin, insects, or bacteria, because it requires additional chemical testing, which is not included in this study. Now for the significance of the study, this study will theoretically help improve the quality assurance of corn kernels, improve the accuracy of the data gathering, and reduce the time required to analyze samples of corn kernels even on a larger scale.
Hello, I'm CORLEONE JOREL G. ZALDARRIAGA, and I'll be discussing the methodology part of our thesis. So for the data gathering, first, the system will determine the type of damage of the kernels in the sample, as well as if the sample consists of healthy kernels overall. So we have 6 different categories So the system will determine what type of damage does the sample has. Next, data that will be obtained will consist of the sample images that would serve as training datasets and validation. So we have captured several images for the training datasets and also for the sample for validation. Next, each sample will consist of 100-gram kernels. So each picture will depict 100-gram kernels. Next, the total number of images were gathered is 1020 images. As you can see in this figure, the 6 different types of damages that we have gathered. So for the colored image edge detection, the image on the left is captured image from the top view of a sample, while on the right is the image that has been modified using Sobel's filter. We apply the colored image edge detection to be able to differentiate the types of damage based from their color externally. By using Sobel's 3x3, we were able to achieve proper filtering in order to accurately determine what type of damage does the sample have. Creating the convolutional neural network. In creating a CNN model, we make use of the different CNN layers to process an image. The layers concerned in this model are the following: filtering, pooling, convolution, and fully connected. Each layer will perform a specific process on the image. Once they have gone through all the layers, they will have a set of defined values that will be considered in determining what type of sample was processed. The CNN we created, we used TensorFlow and Python. Setting up the system. This is the flowchart for setting up the system. The system will start by filling the tray with 100 grams of corn kernel sample. The corn kernel sample will then be spread throughout the tray. If there are overlapping corn kernels, the user can turn on the switch to use the vibration motor to generate vibration at the center of the tray in order to adjust the placement of the kernels. Next, the photos of the sample will then be taken from the top view and the 2 angle views once the corn kernel sample is of an acceptable state. Then transfer the images to the laptop. Then input the sample images to the program. And the program will then be processed the color image edge detection, then the CNN, and determine the category of the sample. Finally, will determine the accuracy of the CNN. Here is a sample of a top view and side view angle that was captured using the system. And here is the results and discussion. So for table 1, we tested a dryer damage. So we have 5 trials. We have 6 different categories. So for this test, we have for dryer damage. So for trial 1, we got correct. Trial 2, correct. Trial 3, correct. Trial 4, correct. And trial 5, correct. So for table 2, we tested the heat damage. That's the sample. Sample is the heat damage. So we have got the correct result. Input was heat damage and the output was heat damage. So from trial 1 to 5, correct. Table 3, the sample is a heat damage dryer phase. So same as the previous, trial 1 to 5, they all got the correct answers. Table 4, test focal type A from trial 1, we got the correct. Trial 2, correct. Trial 3, correct. Trial 4, correct. Trial 5, correct. So we got 100% score here for table 4. Table 5, we have a sample of focal type B. So the input is focal type B. Then the output for trial 1, correct. Focal type B. Trial 2, focal type B, correct. Trial 3, focal type B, correct. Trial 4 and 5, correct. Lastly, for healthy corn kernel damage, corn kernels. So trial 1, correct. Trial 2, we have a mishap that's incorrect. The input was healthy corn kernel, but the output was focal type B. So for trial 3, correct. Trial 4, correct. And trial 5, correct. So we have mishap in trial 2. So for the confusion matrix, reality n is equal to 30. We have 30 tests. So we use a confusion matrix in our statistical treatment. Undamaged true negative is equal to 4, false negative 1, false positive 0, and true positive 25. So the results of the colored image edge detection with convolutional neural network can be seen in tables 1 to 6, based on the values that have been computed using confusion matrix with a summation of JOREL, which is 30. The accuracy that we have is 96.66%, and the misclassification rate is 3.33%.
Now for the conclusion part of our study, it was split into 4 parts which correspond to each objectives that were stated on our introduction. So for the first part, the prototype was able to achieve the hardware specifications and hardware objectives that were set, specifically for the wooden tray that we've made, which houses all the components that we've used in the study, specifically the vibration motors as well as the camera stands for the phone. Second part is the colored image edge detection algorithm was able to effectively detect the edges of the samples. We used the colored image edge detection to space out, or to rather filter out, the empty spaces of the image. And the third part is the convolutional neural network, or CNN, was able to determine the types of the samples, specifically in which type of damage it had, and if it was a healthy sample overall. So for the fourth and final part of our conclusion, the overall accuracy rating of the study was achieved. It was originally targeted as 93.5%. We achieved a final accuracy rating of 96.66%.
Future works for our thesis. First, it's about 3D image. To further improve the spatial data analysis of the convolutional neural network model, stitching the images used in the study to form a 3D image should be considered. Second, the consistency across all sample images can be improved by using better designs for the hardware to achieve more consistency, camera angles, which removes the factor of inconsistent pixel adjacency. Lastly, real-time image classification process can be innovated to the system in order to lessen the time constraint of transferring images from the camera to the laptop. Thank you, and that's all.
We would also like to acknowledge and thank our advisors, Engineer Alan Yumang and Engineer Glenn Maguli, for their help with our thesis, as well as our course instructor, Engineer Yumang Torres. This has been MONTOYA and my groupmate CORLEONE ZALDARRIAGA ending this video presentation. Thank you very much.